Welcome everyone. In this video we're going to do a 14.4 problem that's going to be linearization, tangent planes, all that good stuff. We're here in fall 2015. This is problem number 9. We have a nice two-variable function. And we want to find the linearization or the tangent plane for our function at the point 2, 1. So okay, I remember that we need to go ahead and take some derivatives and plug in this point 2, 1. So that's where I'm going to start here. I'm going to calculate out f sub x first. So the derivative of this with respect to x, it looks like I get 3y minus, 2x, the natural log of y. And now I'm going to go ahead and plug in my specific point. So I'm going to do f sub x at the point 2, 1. So everywhere I see an x, I'm plugging in a 2. Everywhere I see a y, I'm plugging in a 1. So this is going to be 3 minus, 2 times x, that's going to be 4, and then the natural log of 1. The natural log of 1 is 0. So this just gives us a nice even 3. Alright, how about f sub y? So f sub y in this case, again, we're taking a derivative with respect to y. That's going to be 3x minus, it looks like x squared divided by y in this case, right? Because the derivative of the natural log is 1 over. Let's go ahead and plug in our specific value. So f of y at the point 2, 1, or f sub y, the derivative of f with respect to y at 2, 1. Alright, so 2 everywhere I see an x, so this is going to be 6. Minus, alright, so 2 squared, that's going to be 4, divided by y is 1, so we get 6 minus 4, so that's going to be 2. And the last thing we need in order to find the linearization, right, is we need to know what is the function's value at this point. So I need to know what is f of 2, 1. So I'm going to plug in 2 everywhere I see an x, 1 everywhere I see a y, so this is going to be, 3 times 2 times 1, that's going to be 6. Minus x squared, that's going to be 4, and the natural log of y, that's going to be 1. So it looks like when I plug in 2, 1 into my original function, I just get out the value 2. So remember, we have an equation for the linearization. So L of xy, it goes something like f of ab plus f sub x at ab times x minus a plus f sub y at ab times y minus b. So now our specific a value is 2, our b value is 1. We already know what f of 2, 1 is, it's 2. We know what the partial derivative at 2, 1 is with respect to x, that's 3. So this is going to be 3 times x minus, and the x value is 2 in this case, plus, alright, the derivative with respect to y, that looks like 2 times y minus the y value, which is 1. So this right here is my linearization. It's fine to leave it just like this. I would give this answer 100%. Of course, if you want to simplify it down, that's certainly fine. And if you have a multiple choice question or something like this, and maybe it's all the answers are fully simplified down, of course you should be comfortable with that. But I'm happy with this as the final answer. Alright, so that's the big work right there. Part B is use the linearization to actually approximate something. Right? Linearizations are another name for that is linear approximation. So we can use these to approximate things. And so the big thing here is f of xy is approximately equal to L of xy, so long as xy is close to the point AB. So in this case, our point is 2, 1. Here's a point that's relatively close to that, right? 1.9, comma 1.2. So the claim is the linearization will actually do a good job. So if you want f of 1.9, comma 1.2, well, this will be approximately equal to the linearization at 1.9, comma 1.2. And so in this case, well, here's our linearization function. It's going to be 2 plus 3 times, everywhere I see an x, I'm going to plug in a 1.9, 1.9 minus 2, plus 2 times y minus 1, so that's going to be 1.2 minus 1. So we're going to have 2 plus 3, 1.9 minus 2 is going to be negative 0.1, and then plus 2 times, looks like 0.2. So that's going to be 2 minus a 0.3 plus a 0.4. So I think altogether we're going to have 2.1. So again, this is fairly close to 2, which makes sense, right? Because again, 1.9 and comma 1.2 is fairly close to 2, 1. And at 2, 1, the function outputs 2. So since this is a close by point, it makes sense, 2.1. Alright, so there's a nice linearization problem. I hope you guys enjoyed. We got one more video, 14.5, before our first exam. I hope to see you then.